Hello, welcome back. We're going to continue now in our study of phonology. We're going to be doing some examples of phonemic analysis, applying the principles that we learned last time. Phonology, remember, is our next step on the ladder on top of phonetics. It's not about the mechanics of how sounds are articulated, it's rather about the structure of sounds and really the structure of systems of sounds as they exist in languages. The key idea on which really all of phonology is based is this distinction between contrastive and non-contrastive sounds in a language. Two sounds are contrastive in a language if and only if interchanging the two sounds makes a difference for what word you're saying. So this means that contrastive sounds are sounds such that the difference between them is useful for signaling a difference in meaning of a word. So when you interchange the sounds, you get a totally different word, a totally different meaning. We're starting to see now this connection between sound and meaning that makes human language so interesting. The diagnostic test for contrastiveness is there any minimal pair for two sounds in a language? So remember, minimal pair means two different words, distinct words with different meanings that differ only in one sound. For example, we looked at the sounds n, the alveolar nasal, and the sound eng, the velar nasal in English, and we asked, are these contrastive? Can you find a minimal pair, two words, separate words, which differ only in these two sounds? And you can think about it, and you might come up with minimal pairs like kin and king. Two words, totally separate meanings, they differ only in this one sound. It shows these two sounds are contrastive. Now, can you think of any other examples, any other minimal pairs that would demonstrate that the distinction between n and eng is contrastive? I'll give you a moment to think about it. There's quite a few. Recalling that this sound eng only shows up in syllable offsets, syllable rhymes rather, let's take a look. There's gone and gong. Two totally different words, they differ only in this sound, so the two sounds are contrastive in English. Another example would be the sound unaspirated, unvoiced bilabial stop ba, as in spat, and the aspirated, unvoiced bilabial stop p, as in pat. Are these contrastive in English? Can you find an example where you have a word that has the unaspirated sound b, and then you drop in the aspirated sound p instead, and you get a different word in English? Are they contrastive? Well, using our canonical examples for these sounds, we can see if we can form a minimal pair using these. So you can take spat, that has an unaspirated, unvoiced bilabial stop b, spat. You can try dropping in the aspirated sound instead, and you get spat, and it is not a different word, spat. It is just a sort of weird way of pronouncing spat, right? So you interchange the sounds, you don't get a different word, you just get a variant of the same word, or you get something unpronounceable. And so there are, in fact, no minimal pairs for this pair of sounds in English. Therefore, we have no evidence that the sounds are contrastive in English. This idea of contrastivity leads us to this idea of phonemes and allophones. A phoneme is a single underlying sound, a mental entity, a mental unit of sound, which can be expressed as multiple phonetic variants, which are called allophones. Speakers of a language might perceive allophones of a phoneme as the same sound. They might or they might not, so be careful. If two sounds are contrastive, they must come from different phonemes. So, for example, we saw this sort of triangle of opposition in English. We have a contrastive difference between the sound aspirated p, as in pat, and voiced b, as in bat. Those are contrastive. We can draw a contrast between the unaspirated p, as in lap, and the voiced b, as in lab. Those are contrastive. But there is no contrast between the aspirated and unaspirated, unvoiced bilabial stops, p as in pat and b as in spat. Those are not contrastive. And so we say that those two sounds are actually two variants of the same underlying thing. And what is that underlying thing? It's the phoneme P in English. So the phoneme P appears in these two different guises depending on the context. It can manifest as different sounds in speech, but underlyingly it's the same mental category, the phoneme P. And the thing it's contrasted with here is the phoneme B in English. Remember, we write phonemes in these slashes. We write sounds in brackets and we write phonemes in slashes. When you see slashes, you should read that as the phoneme B. So English has this kind of phonemic structure. We have our phonemes, which are realized as allophones. The phoneme underlying P is realized as the sound P as in pat, or the sound unaspirated B as in spat. And the phoneme B, the voiced bilabial stop, is realized as a voiced bilabial stop. Many times, although not always, allophones of the same phoneme are in what we call complementary distribution. When allophones are in complementary distribution, that means that there is a conditioning environment. There's some phonetic environment which determines which allophones will appear. So basically, in one phonetic context, you get one allophone. In another phonetic context, you get the other allophone. That's complementary distribution. Free variation, on the other hand, free variation means that the choice of allophones is basically random. So in the same environment, you might get one allophone or the other. That's free variation. Complementary distribution means the context determines the allophone. Like Clark Kent and Superman. You never see them together in the same context. On an ordinary day, you see Clark Kent. In a situation of distress, you see Superman. Depending on the context, this same underlying entity will appear in different forms. Similarly, the phoneme P in English appears as the sound unaspirated P as in spat when it occurs after S and at ends of words in some other contexts. And otherwise, elsewhere, it shows up as the sound aspirated P as in pat. So this thing here is what we call the conditioning environment for the sound unaspirated P as in spat. After S and at ends of words, that's what determines that you're going to get this sound rather than the other, realizing the underlying phoneme P. So what I want to do now is take these ideas and systematize them. We're going to systematize them using this concept of phonological rules. We've noticed that in languages there's these certain regular patterns in terms of how underlying sounds are expressed. The notion of a phonological rule is a way for us as scientists to describe those patterns in a systematic way. So remember, phonemes are abstract mental categories, and phones are concrete physical sounds that realize them. What exactly is the link between them? We describe that link using phonological rules. A phonological rule is a thing you write down which describes how underlying phonemes translate into the actual phones. Equivalently, a rule is a way of describing which allophones appear in which conditioning environments. For example, when you say something like the phoneme P is expressed as the sound B after S, as B or the unreleased at word endings, and as aspirated P elsewhere, that's a phonological rule. You've stated how an underlying phoneme is expressed as an actual sound in different contexts. And the underlined parts of this are what we call the conditioning environments. When allophones are in complementary distribution, there are conditioning environments that determine which allophone you get. So the idea is that when you're describing, say, the structure of a word, the sound structure of a word, you start with an underlying phonemic form, which is just the sequence of phonemes. That's also called an underlying form. Then you apply the rules in order to generate or derive the phonetic form. Here's what that looks like. You have an underlying phonemic form. You apply a bunch of phonological rules, and you get out a phonetic form. For example, you might ask how an underlying form, like say this, representing the word pat in English, is translated into the phonetic form which you can actually pronounce and hear. So we have a phonemic form, which consists of the phoneme p followed by the phoneme a followed by the phoneme t in English. Now the idea is we want to apply the phonological rules, which apply to all the different phonemes in this underlying form, until at the end of the day we have the phonetic form. So the first thing you would do is apply the rule that says the phoneme p is expressed as the sound aspirated p, except after the sound s, word endings of words. So what is going to happen when we apply that rule to the phonemic form? Well, we're going to get an aspirated p in this context. So you do that. You also apply whatever rules you have for a and t, the phonemes. And at the end of the day, you get the phonetic form, the sequence of sounds pat, with an aspirated p and an unreleased t, and an oral a. So you can think of phonological rules as like a series of instructions which tell you how do you translate an underlying phonemic form into an actual phonetic form that you can observe in speech. Another example. What determines whether you say the vowel nasalized a or the vowel oral a, both of which are allophones of the phoneme a in English? So based on the data that we've gathered before, that we gathered in the last class when we looked at words like can and cat, we concluded that the phoneme a appears in a distribution that looks like this, which we can summarize in a table that looks like this. So it appears as a certain different phone depending on a conditioning environment. That's complementary distribution. It appears as the sound nasalized a when it appears before an M, as in a word like ram or lamb. It appears as a nasalized a when it appears before the sound N, the alveolar nasal N, as in ran. It appears as the sound nasalized a when it appears before an eng, as in the word rang. And it appears as an unnasalized vowel a elsewhere, everywhere else. So we can summarize the distribution of the allophones using a table like this. And we actually can write this in a special way. As linguists, we have a special format for writing phonological rules. It looks like this. The phoneme a is expressed as the sound nasalized a when it appears before m. This is a special format for writing phonological rules. It's like the underlying phoneme there, written in slashes, is being translated into the sound, which is written in brackets. And then the thing after the slash tells you the conditioning environment. So the rule for the set of rules for a in English looks like this. The phoneme a is expressed as the sound nasalized a when it appears before m, and before n, and before eng, and it's expressed as the sound unnasalized a elsewhere. The general format for a rule is you write the phoneme, and then the arrow, and then the phone, and then the slash, and then the conditioning environment. So when you see rules like this, the way to read them is like this. You say the phoneme a, that's the low front, lax, unrounded vowel in English. The phoneme a is expressed as the sound a when it appears elsewhere. And the phoneme a is expressed as the sound nasalized a when it appears before eng, and so on. So we can also write the rules in an even more terse way. This is a more technical way of writing phonological rules. It's also a bit more precise. You can write them like this. This would be an alternative way to write the phonological rules which describe the distribution of allophones of the phoneme a in English. So the way to read this is that the one on top would be like the phoneme a is expressed as the sound nasalized a when it appears before m, indicated with the underscore, the blank spot there indicates where the relevant phoneme is. And this indicates that it appears right before an m. So if you see the phoneme right before an m, then it's going to be expressed as the sound nasalized a in English. We can also generalize these rules. So when you look at how these rules are written here, it's kind of redundant, right? I've given this rule which turns the vowel, the phoneme a, into the sound eh, redundantly 3 different times. What's up with that? So there must be some way to abstract away what's going on here, to write this in a more terse and succinct way. To do that, we note that the sounds m, n, and ang, which appear as conditioning environments for the nasalized vowel eh, that is a set of phones which forms something called a natural class. A natural class is any set of phones that share some phonetic feature. And they share that feature to the exclusion of others. So if I ask you, what's the feature in common among m, n, and ang? Well, it's not that they share a place of articulation, because m is bilabial, n is alveolar, and ang is velar. It's not that they share other features. The feature that they share is that they're all nasal. Their manner of articulation is all nasal. So we can say that the rule here is actually that the phoneme a is expressed as the sound nasalized eh when it appears before nasal consonants. Before nasal consonants, that is a natural class that summarizes the set of sounds m, n, and ang, which share the feature of nasality. And it is expressed as the sound unnasalized oral a elsewhere. So it turns out that when you look at the phonological rules which describe phonological patterns across many different languages, the conditioning environments for allophones are usually determined by these natural classes. So this kind of rule is really, really common. This is a rule where the conditioning environment is determined by a natural class, in this case, of the following consonant. In fact, usually the allophones are determined only by a few features of the phonetic environment. These natural classes of phones are mostly defined by the phonetic features we've studied before, but there are a few special natural classes which show up very frequently in phonological rules, which involve sort of slightly different combinations of these features. So what I'm going to do now is list a few of the common natural classes, common sets of phonemes, rather common sets of sounds that you're going to commonly see in conditioning environments for phonological rules. So some other common natural classes are things like obstruents. Obstruents is a natural class of sounds which includes all stops, fricatives, and affricates. These are all the sounds that involve stopping airflow or creating friction in the mouth, to the exclusion of consonants like approximants, which don't involve friction or stoppage in the mouth, and to the exclusion of things like vowels. Those things are called sonorants. Sonorants are any sounds that are not obstruents, so that includes both approximants and vowels. You'll also often see rules applying in conditioning environments based on the natural class of labials. Labials are either bilabial or labiodental consonants in terms of their place of articulation. These are consonants that basically involve the lips in any way. And another very common natural class is what's called sibilants. Sibilants are sounds that sort of make a hissing sound or a buzzing sound. These are the sounds like s, z, esh, j, ch, j. So these are basically your alveolar and post-alveolar fricatives and affricates. Those are called together the natural class of sibilants. So let's look at some examples of natural classes. I'm going to show you some sets of sounds, and I want you to identify the natural class. So if you see some phonological rule determined by a conditioning environment that consists of these sets of sounds, then you should be able to identify, abstract out the natural class that describes that set. So the set of sounds v, el, es, je. What are these? Well, think about what features they have in common. V, the, z, je. So they're all voiced. That's the first thing you should notice. And let's see, do we see any vowels here? No. Do we see any approximants here? No. Do we see any stops here? Things like d And k that involve total stoppage of airflow. Do we see stops? No. What we see is only fricatives. In fact, it's voiced fricatives. That would be the natural class defined by this little set. Another example, the vowels a and ah. A and ah. What is the common feature in this set? So a is front and low. Ah is back and low. What's in common is they're both low. So this is the set of low and also unrounded vowels, a and ah. How about this set? We have the stop b, we have the fricative v, we have the stop d and g, we have the fricatives z and j. Now remember, what is the natural class that encompasses both fricatives and stops? That's right, it's obstruents. And are these all voiced or are they all unvoiced? They're all voiced. So this is the natural class that you would call voiced obstruents. And this one, we have the sound M, the sound P, the sound B, the sound F. So the places of articulation here are bilabial, labiodental, and at the last one there is a W that's labial velar. What's the natural class? These are labial consonants. They all involve the lips. Ka, ga, nga. What's in common here? If you just say ka, ga, nga, you're going to feel that it's the same place of articulation, which is velar. And some of these are voiced, some are unvoiced. So this is the natural class of velar consonants. So that is an example in identifying and abstracting natural classes. What I want to do now is identify natural classes as they are applied in a phonological rule. So I'm going to ask, what is the conditioning environment for the sound unaspirated d versus the sound aspirated t as allophones of the phoneme t in syllable onsets in single syllable words in English? So I'll give you some data. So we have the word stop, which is realized as the sequence of sounds stop with an unaspirated t. We have the word top, which appears as a sequence of sounds starting with an aspirated t. Then we have the word shtick, actually a loan word from the Yiddish language into the English language, shtick, but the way it's realized in terms of sounds phonetically is sh, t, k, so it has an unaspirated t. So it looks like the distribution of allophones is, we have that the phoneme t is expressed as the sound unaspirated t after the sound s. The phoneme t is expressed as the sound unaspirated t after esh, the post-alveolar fricative. And we have that the phoneme t is expressed as the sound aspirated t elsewhere. So what then is the conditioning environment in terms of natural classes for the unaspirated t, as in stop? What is that? Well, we have s and we have esh. So what's the natural class here? Well, we can think about the voicing, s and esh, both unvoiced. We can think about the places of articulation. S is alveolar, esh is post-alveolar. But what is the natural class that encompasses both of these sounds, s and esh, these sort of hissing sounds? Remember, those are sibilants. The natural class that contains these two things is unvoiced sibilants. So we can write the rule for English like this. We have that the phoneme t is expressed as the sound unaspirated t after voiced sibilants. And the phoneme t is expressed as the sound aspirated t when it appears elsewhere. Everything we've been doing so far constitutes what's called phonemic analysis. Phonemic analysis is when you take a language and you figure out what are the phonemes, and what are the allophones, and what are the rules that determine the distribution of the allophones. Phonemic analysis is often the first step that you take when you're describing a language. So imagine that you are a scientist, a linguist. You go to some village of people in some remote part of the world speaking a language which has never been described before. And you want to write down how their language works. You want to create a grammar of their language so you can describe it to other linguists. The first step you would take in describing a language like that is typically phonemic analysis. So we're going to do some examples now of phonemic analysis on languages other than English. I'm going to give you some data, and we're going to go through phonemic analysis as applied to that data. Phonemic analysis is the process of identifying phonemes, allophones, and phonological rules that link them together in a language. Here's the steps. First, you identify minimal pairs to figure out which sounds are contrastive. You identify which sounds are phonemes versus allophones by finding minimal pairs. Next step is to list out the phonetic environments that you see for each allophone of the same underlying phoneme. Next, you determine which allophones are in complementary distribution and which ones are in free variation, based on that list of phonetic environments. Next, for the allophones that are in complementary distribution, you identify the natural classes in the conditioning environments for those allophones that are in complementary distribution. Lastly, you write down the rules using those natural classes. So here's our first example. We're going to look at Italian. So this is not assuming you know Italian. This is imagining that you've gone into a village of people speaking an unknown language. It turns out to be Italian, but let's say that the Italian language has never been described yet, and you are the first person describing this language. And you've gone to people and you've asked for lists of words, like you asked, what's the word for die? And the person said tinta, and you wrote that down phonetically. You ask for lots of different words, you write them down phonetically, and then you can do a phonemic analysis. So here's our data. Our first step is to use minimal pairs to determine which sounds are phonemes and which sounds are allophones. Here's a possible distinction that you might notice. So when you're transcribing the sounds of the Italian speakers, you notice that some words have the sound E, some words have the sound E, and you can see examples of those in the word list. And now the question is, are the sounds E and E different phonemes in Italian? We answer by looking for minimal pairs. So we go down the list. We want to find two distinct words which differ only in that one has E and the other one has E. So, okay, the first word here is tinta. And so we might look down that and say, okay, do we have a word which differs only in that it has the sound E instead of E? Like that would be tenta. Let's take a look. Well, we have tenda, but that's a near miss. That's not a minimal pair because tenda also is different in that it has the sound D, voiced D, instead of the sound T, unvoiced T. So tenda does not form a minimal pair with tinta. We keep going down the list, and we don't find any minimal pairs. Okay, so let's keep looking. Keep looking until you either find a minimal pair or you exhaust all your data. So we can go down and down and down. Here's another example of E in tingo, which means I die. Like I dye something purple, not like I stop living. So do we find any minimal pairs? So do we find anything in the list which is like tingo, except that it has the vowel E and it means something different? Well, it's right below it in this list. Tengo means I keep. We have a minimal pair, tingo, tengo, therefore the sounds E and E are contrastive in Italian. So those are two different phonemes. E and E are realizing two different phonemes. Now, how about N and eng? The alveolar nasal N and the velar nasal eng. Are these different phonemes in Italian? Well, take a look. Take a look at the list. Do you see any minimal pairs? So let's look for examples of N, like in tinta. Do we see any other words which are the same, but they have an eng? They're the same phonetically, except that they have an eng, and they mean something different. So for tinta, we were looking for something like tinta. Do we see tinta? No, not really. And you can keep on looking, and you won't find a minimal pair for these two sounds in Italian. We conclude that these two sounds are not contrastive. In fact, they are allophones of the same underlying phoneme. Now, this is different from English. Remember, in English, these are actually contrastive. In Italian, given this data, they're not contrastive. So let's continue the phonemic analysis. We have to list the phonetic environments for N and eng in order to determine the distribution of the allophones N and eng. Based on that, we can figure out if they're in complementary distribution or free variation, and if they're in complementary distribution, we can identify the conditioning environments. So here are all the words in their phonetic forms, which include the sound N. We have tinta, tenda, danza, nero, sapone, and gente. And here are all the words that contain the sound eng. We have tingo, tengo, fungo, bianca, anche, and fango. Okay, so now we want to figure out, is there anything in common in the phonetic environments which determines that you're going to get the sound velar eng instead of the sound alveolar n? So let's just look at the list. What is it? Well, what do you see in common among the words that have an eng instead of an n? What do you see in common? You might wonder if maybe it's the vowel that comes before. Maybe the vowel that comes before determines which allophone you get. And so you look and you see, it can't really be that, because I have tingo with an E before, and I have tinta, which also has an E before. And so it can't be the preceding vowel which determines the allophone. No, the thing that's in common, if you look at the eng column, the thing that's in common here is that the sound is always appearing before the sound which is the voiced velar stop g, or before the sound which is the unvoiced velar stop k. Okay, so we've figured out that you get an eng when it appears before a g or a k. What's the natural class that includes the voiced and unvoiced velar stops? It's velar stops. So the last step is to identify those natural classes that define the conditioning environments and write down the rules. We have that the phoneme n is expressed as the sound velar eng when it appears before velar stops, and the phoneme n is expressed as the sound alveolar n elsewhere. That completes our phonemic analysis of these two allophones in Italian. And again, if you are working in language documentation, which is when you go into a community and write down how their language works, then you're going to do this phonemic analysis for all the sounds in the language. That's the first step, usually, of developing a linguistic description. Now we'll do a second example. The second example is going to be on the language Ganda, which is one of the major languages spoken in Uganda. This is a Bantu language. So we've collected a list of words and their pronunciations. These are actually the writing in the Ganda orthography, but we can just sort of pretend for now that these are actually IPA symbols. So the question is going to be, do the sounds L, which is the voiced alveolar lateral approximant, and the sound R, which is the voiced alveolar trill, do these represent different phonemes in Ganda? No, there's no minimal pairs. If you look through the list, you won't find any words which differ only in the substitution of L for R and have different meanings. They're not minimal pairs. In fact, they're in complementary distribution, and we're going to do the phonemic analysis to figure out their distribution. They're allophones of the same phoneme. All right, so to do the phonemic analysis, for remember the R and the L here, we're going to, the first step is to list the phonetic environments for the different sounds. So let's see. We have the sound, the alveolar trill, and we have the sound, the voiced alveolar lateral approximant. Let's look at examples of words that have these two sounds. So we have, looking first at the trill, r. What's the first thing we see in the list that has this sound? Well, it's apparently the verb tell, so that is bulira. Okay. And what's the next thing in the list? Well, that would be, it looks like, the word for hospital, which is something like eddualiro. And let's keep looking through the list, looking for the R. Well, eventually we see the word ulira, which means to hear. And we can go so on and so on. We have the word bera underlined there, and then we have the word yukira. and a word like eriato. So, and we can keep on going and doing the whole list, but in fact, this set of examples is enough to figure it out. And now we need to look at the environments in which we get instead the sound L. That's the alveolar voiced lateral approximant. So that shows up in words like cola, shows up in words like Luana, shows up in words like bulira, which also shows up in the other list as an example of the R. And it shows up in words like lua, in words like lula, twice, and words like omugole, and again, so on and so on. You can list them all out. In fact, this set is enough to figure out what's going on there. So the question is, what is the common element in the environments for the sound as opposed to the sound L? So what is it? What determines that you're going to get the trill R as opposed to the lateral approximant L in Ganda? So let's take a look at the phonetic environments in which the two sounds appear. In bulira, we have the sound R appearing after the vowel E and before the vowel A. So now maybe you think, okay, maybe it's that following vowel A. Maybe you get a trill R when it appears before an A. Could that be it? Well, then take a look at the other column. So we have here cola, also appearing before the vowel A, but there we have the allophone L. And so it's not that. It's not the vowel that follows that determines which allophone you get. Instead, let's look at the vowel which comes before. So we have bulira, we have eddualiro, we have ulira. What is the common element here? These all appear after the sound E, which is the high front unrounded vowel. And if we look in the L column, we don't see any examples of L appearing after that vowel E. Then as we keep on going down the R column, so we notice that we have bulira, we have eddualiro, we have ulira, then we have bera, a little different. So after the vowel A, which is the mid-front unrounded vowel A, we have again the trill R, and we don't see any examples in the L column where they're appearing after that vowel A. All right. Then in yukira, we have again appearing after the vowel E, and in eriato, we have appearing after the vowel A. So how would we summarize this? We can say the sound R is appearing after the sound A or the sound E. All right. Now, what is the natural class that encompasses these two vowels? So remember, A is the mid-front unrounded vowel, E is the high front unrounded vowel. What do they have in common? That's right, they're both front vowels. So we can say these are both front, and they are mid or high in terms of their tongue height vowels. And so now we're ready to write down our phonological rules. They look like this. The underlying phoneme L is expressed as the sound R when it appears after front vowels. And the phoneme L is expressed as the sound L when it appears everywhere else. So that is the phonemic analysis for this particular contrast in Ganda. So, to summarize phonemic analysis is the process of identifying phonemes, allophones, and the phonological rules that link them together in a language. Step 1, you use minimal pairs to identify which sounds are phonemes and which ones are allophones. Step 2, you list the phonetic environments observed for each allophone. Step 3, you determine which allophones are in complementary distribution and which are in free variation. Step 4, for those allophones that are in complementary distribution, you identify the natural classes that comprise the conditioning environments. Step 5, write down the rules. Now you know phonemic analysis.